What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to deal with binomial theorem and explain what does that mean when we are talking about binomial expression and binomial theorem and binomial coefficient, and I will go through some examples. So an algebraic expression consisting of two terms which are connected by plus or minus sign is called a binomial expression. So binomial means two terms. Binomial theorem: if n is a natural number and a and b are any real numbers, then we can say a plus b in bracket to the power of n equals to cn0 a to the power of n b to the power of 0 plus cn1 a to the power of n minus 1 b to the power of 1 and so on up to get Cn of n, or choose nn, a to the power of 0, b to the power of n. The binomial theorem describes the algebraic expansion of powers of a binomial. Before I go through the examples, I just want to show you the Pascal triangle. Pascal triangle is going to show you the combination of different numbers. For example, on the first line you have C00, then you have C1011, 202122, and on the third line we have 30313233, and on the fourth line you have C4041, 42, 43, and 44. When you calculate it for each of them and evaluate it, you're gonna have something like that, and you can expand it even more. So the 0th line is gonna be only 1. Then on the first line you have 1 and 1, and after that you can have 1 for the sides, and then the rest of it is going to be the summation of the two top numbers. For example, 1 plus 1 is going to be 2, 2 plus 1 is going to be 3, 1 plus 2 is going to be 3, 3 plus 3 is 6, 3 plus 1 is 4, 3 plus 1 is 4, or 5 and 10 is going to be 15, or 6 and 15 is going to be 21. So that's basically how we construct Pascal triangle. So 0th line, first line, second line, third line, and you can find it from the first term here as well. Second line, third line, fourth line, fifth line, and so on. So this triangle, which is called Pascal triangle, is very important in binomial expansion. Let's see some examples. So the first expansion is a plus b to the power of 0. We know any expression to the power of 0 is going to be just 1. That's it. A plus b to the power of 1. So we are talking about the first line in Pascal's triangle, which is going to be 1 and 1. So we have the answer is going to be 1 times a plus 1 times b, or a plus b, which makes sense because any expression to the power of 1 is going to be the same thing. Now next one we need to use the second line, 1 2 1, 1 2 1, and if we just sub it in binomial theorem formula, a plus b to the power of 2, we're gonna end up having 3 terms. So that's gonna be C20 a to the power of 2 b to the power of 0 plus C21 a to the power of 1 b to the power of 1 plus C22 a to the power of 0 b to the power of 2. That's gonna be C20 is gonna be 1, so that's gonna be and b to the power of 0 is 1 as well, so that's gonna be just a squared plus the second term, C21 is gonna be 2, as you saw it in Pascal triangle. A to the power of 1 b to the power of 1 is gonna be just the same thing. And the last one, a to the power of 0 is 1. C 2 choose 2 is going to be 1, so we have b squared. So that's a squared plus 2ab plus b squared. So now let's see the next one. A plus b to the power of 3. So that's going to be 3c0 a to the power of 3 b to the power of 0 plus 3c1 a to the power of 3 minus 1. So the exponent of the first term is going down and exponent of the second term is going up. So the previous one, it was b to the power of 0. Now it's going to be b to the power of 1 plus 3c2 a to the power of 1 b to the power of 2 plus 3c3 a to the power of 0 b to the power of 3. So that's going to be 3c0 is 1. And you can also, for coefficient, instead of just evaluating this, and this, you can use the third line on the Pascal's triangle, 1, 3, 3, 1. So this one is 1, 3, 3, 1. So you don't need to really calculate it. And in case you want to calculate it, when you have C and you have n and r, which called NCR, you have n factorial over n minus r factorial times r factorial. That's how you calculate it. So then it's going to be, the first one is 1, b to the power of 0 is 1, so we have a cubed plus, this term is 3a squared b1, so it's going to be 3a squared b plus 3ab squared plus 1, a squared is 1, b to the power of 3. So that's going to be the answer to the expansion. Next one, a plus b to the power of 4. So that's going to be 4c0 a to the power of 4 b to the power of 0 plus 4c1 a to the power of 3. As you see here again, the first term is going down, the exponent, and b is going up. B to the power of 1 plus 4c2 a to the power of 2 b to the power of 2 plus 4c3 a to the power of 1 b to the power of 3, and finally 4c4 a to the power of 0 b to the power of 4. So that's going to be, the first term is going to be 1. If you want to find the coefficients here again, you can have two options. One of them is to use the formula that I just showed you, this formula, or you can use the Pascal's triangle. So that's fourth 9. So it means that we have 5 terms, 1, 2, 3, 4, 5 terms, and we have 5 coefficients, 1, 4, 6, 4, 1. So this one is 1, 4, 6, 4, 1. So 1 times a to the power of 4, b to the power of 0, b to the power of 0 is 1, so it's going to be a to the power of 4, plus 4 a to the power of 3, b to the power of 1, which is going to be just b. Then you have 6 a to the power of 2, b to the power of 2, plus 4a b to the power of 3, plus, the last one is going to be also 1, a to the power of 0 is 1, it's going to be just b to the power of 4. So as you see here, when you have to the power of 4, we have 5 terms. When it's to the power of 3, we have 4 terms. To the power of 2, we have 3 terms. Next one, a plus b to the power of 5. So that's going to be 5c0 a to the power of 5 b to the power of 0 plus 5c1 a to the power of 4 b to the power of 1 plus 5c2 a to the power of 3 b to the power of 2, then 5c3 a to the power of 2 b to the power of 3, 5c4 a to the power of 1 b to the power of 4, and finally we have 5c5 a to the power of 0 b to the power of 5. One thing which is interesting is the exponent is 5, and if you look at the terms here, when you add the exponents, always for each term is going to be 5 as well. 5 plus 0 is 5. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 1 plus 4, 0 plus 5. We have the same thing here. It was 4 in here. 4 plus 0, or 3 plus 1, 2 plus 2, 1 plus 3, and 0 plus 1. All of them are 4. Now, again, for evaluation, we need to find out the formula, or we need to use the Pascal triangle. Now, we are talking about to the power of 5, so we need to look for fifth term. So 1, 5, 10, 10, 5, 1. These are the coefficients of this number. 1, 5, 10, 10, 5, 1. So that's going to be a 5 plus 5a4b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the power 4 plus 1 times b to the power 5. That's going to be the answer. Next example. In this example, the first term is a, the second term is negative b, because it's, in reality it's a plus negative b to the power of 2. So that's going to be 2c0 a to the power of 2 negative b to the power of 0 plus c2 1 a to the power of 1 negative b to the power of 1 plus 2 a to the power of 0 negative b to the power of 2. So this one is 1, this one is 1, so a squared plus this one is 2a negative b plus 1 times negative b to the power of 2 is going to be just b to the power of 2, because any negative number to the power of even number is going to be positive. So that's going to be a squared minus 2ab plus b squared. So that's going to be the expansion here. Next one, a minus b to the power of 3. So it's going to be the very similar formula to this one, but instead of b, you need to put negative b, negative b, negative b, negative b. So that's going to be a cubed minus 3a squared b plus 3ab squared minus b cubed. So it's very similar to a plus b to the power of 3, but since b is negative, we have negative b as a second term, these two terms are going to be negative. Now let's look at a minus b to the power of 4. Now you need to compare it with this guy here. Instead of b, if you have negative b, this term is going to be negative, and also this term is going to be negative. So the second term and fourth term is going to be negative. So we have a to the power of 4 minus 4a cubed b plus 6a squared b squared minus 4a b cubed plus b to the power of 4. Next one, a minus b to the power of 5. Same thing, we need to follow this. That's going to be a to the power of 5. Instead of 5a to the power of 4b, we're going to have negative 5a to the power of 4b plus 10a cubed b squared, because that's to the power of 2. It's going to be positive for sure. Then negative 10a squared b cubed plus 5ab to the power of 4 minus b to the power of 5. That's going to be the expansion of a minus b to the power of 5. Now, next example, it says expand 1 plus m to the power of 4. So that's to the power of 4. It means that we have 5 terms. So if I use binomial theorem, 1 plus m to the power of 4, that's going to be c4 0, 1 to the power of 4, m to the power of 0 plus 4c1, 1 to the power of 3, m to the power of 1 plus 4c2, 1 to the power of 2, m to the power of 2 plus 4c3, 1 to the power of 1 m to the power of 3 plus 4c4 1 to the power of 0 m to the power of 4. When you simplify it, the first one is going to be 1. Again, you need to calculate it or you need to use Pascal triangle, which is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1 are the 5 coefficients. So when you sub it here, it's going to be 1 times 1 to the power of 4 times m to the power of 0. That's going to be just 1. Plus 4c1, that's 4, using the Pascal's triangle. 1 to the power of 3 is 1. M to the power of 1 is m. Plus 4c2, that's 6. 1 to the power of 2 is 1. M squared. Plus 4c3 is 4 times 1 is 4 again. M cubed. Plus 4c4 is 1 again. 1 to the power of 0 is 1 times m to the power of 4 is going to be m to the power of 4. So we're going to say that's 1 plus 4m plus 6m squared plus 4m cubed plus m to the power of 4. So that's going to be the expansion of 1 plus m to the power of 4. Now let's look at this example. Expand a plus x, ax plus b to the power of 3. So if I look at the Pascal triangle, it's going to be 1, 3, 3, 1. So 4 terms. So that's going to be ax plus b to the power of 3 is going to be 3c0 ax to the power of 3 b to the power of 0 plus 3c1 ax to the power of 2 b to the power of 1 plus 3c2 ax to the power of 1 b to the power of 2 plus 3c3 ax to the power of 0 b to the power of 3. So that's going to be, this one is 1, b to the power of 0 is 1, so it's going to be ax to the power of 3 plus 3c1 is 3 times ax to the power of 2 times b plus 3c2 again is going to be 3 times ax times b squared plus 3c3 is going to be 1, ax to the power of 0 is 1, so it's going to be b cubed. I wrote it over there. So when you expand it, when you simplify it, it's going to be a cubed x cubed plus 3a squared bx squared plus 3ab squared x plus b cubed. So that's the expansion for ax plus b to the power of 3. So now next example, it says expand 2x minus 3 to the power of 3. So what I need to do, I'm gonna say 2x minus 3 to the power of 3. It's gonna be, since it's to the power of 3, we're gonna use the third line, 1, 3, 3, 1. We have 4 terms. So it's gonna be 1 times 2x to the power of 3 negative 3 to the power of 0 plus 3 2x to the power of 2 negative 3 to the power of 1 plus 3 2x times negative 3 to the power of 2 plus 1 times 2x to the power of 0 negative 3 to the power of 3. 1 is 0, negative 3 to the power of 0 is 1. So we have 2x to the power of 3. Then here you have negative 3 times 3 is going to be negative 9 times 2x to the power of 2. Here we have 3 times negative 3 to the power of 2. That's going to be 27 times 2x. And here we have 2x to the power of 0, which is 1, times 1 is 1. Negative 3 to the power of 3 is going to be negative 27. So that's going to be 8x cubed minus 36x squared plus 54x minus 27. So that's going to be the expansion for 2x minus 3 to the power of 3. Next example is expand x plus y to the power of 8. So what we need to do, I'm going to have x plus y to the power of 8 is going to be, so instead of NCR, you can also write N choose R. That's going to give you the same concept. So x plus y to the power of 8 is going to be 8 choose 0 x to the power of 8 y to the power of 0 plus 8 choose 1 x to the power of 7 y to the power of 1 plus 8 choose 2 x to the power of 6 y to the power of 2 8 choose 3 x to the power of 5 y to the power of 3 plus 8 choose 4 x to the power of 4 y to the power of 4 plus 8 choose 5 x to the power of 3 y to the power of 5 plus 8 choose 6 x to the power of 2 y to the power of 6 plus 8 choose 7 x to the power of 1 y to the power of 7 and finally 8 choose 8 x to the power of 0 y to the power of 8. So when you simplify it, you can calculate all these 9 coefficients, or you can use the 8th line of the Pascal triangle. 1, 8, 28, 56, 70, 56, 28, 8, and 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. That makes sense. So the first one is 1. Y to the power of 0 is 1, so we have x to the power of 8 plus 8x to the power of 7 times y plus 28x to the power of 6 y to the power of 2 plus 56x to the power of 5 y to the power of 3 plus 70x to the power of 4 y to the power of 4 plus 56a to the power of 3 y to the power of 5 plus 28x to the power of 2 y to the power of 6 plus 8x y to the power of 7 plus y to the power of 8. So that's going to be the expansion of x plus y to the power of 8. Next example is expand 1 over x plus 2x squared to the power of 4. So 1 over x plus 2x squared to the power of 4. That's going to be 4 choose 0, 1 over x to the power of 4, 2x squared to the power of 0, plus 4 choose 1, 1 over x to the power of 3, 2x squared to the power of 1, plus 4 choose 2, 1 over x to the power of 2, 2x squared to the power of 2, plus 4 choose 3, 1 over x to the power of 1, 2x squared to the power of 3, and finally 4 choose 4, 1 over x to the power of 0, 2x squared to the power of 4. So as you see here, the exponent of the first term is decreasing, and the exponent of the second term is increasing 0, 1, 2, 3, 4. And we can use the Pascal triangle to find out the coefficients. We have 1, 4, 6, 4, 1 for these 5 terms. So the first one is 1. This one to the power of 0 is 1. So it's going to be 1 over x to the power of 4 plus 4 choose 1 is 4 times 2 is going to be 8 x squared divided by x to the power of 3, which when you simplify it is going to be 8 over x plus 4 choose 2 is going to be 6 times 2 to the power of 2 is going to be 24. X squared to the power of 2 is going to be x to the power of 4 divided by x squared is going to be x squared. 4 choose 3 is going to be 4. 2 to the power of 3 is going to be 8. 4 times 8 is going to be 32. X to the power of 2 to the power of 3 is going to be x to the power of 6 divided by x is going to be x to the power of 5. Plus 4 choose 4 is going to be 1. 1 over x to the power of 0 is going to be 1. 2x squared to the power of 4 is going to be 16. X to the power of 8. So that's going to be the expansion of 1 over x plus 2x squared to the power of 4. Next one is expand x cubed minus 1 over x squared to the power of 3. So x cubed minus 1 over x squared to the power of 3. So if we use the Pascal triangle, it's going to be 1, 3, 3, 1. So 1 times x to the power of 3 to the power of 3 times 1 minus x squared to the power of 0 plus 3 times x cubed to the power of 2 negative 1 over x squared to the power of 1 plus 3 times x cubed to the power of 1 negative 1 over x squared to the power of 2 plus 1 times x to the power of 3 to the power of 0 minus 1 over x squared to the power of 3. So when you simplify it, this one is 1, this one is 1, so it's going to be x to the power of 3 to the power of 3 is going to be x to the power of 9. Here negative and negative 3 is going to be negative 3. X to the power of 6 divided by x to the power of 2. Here negative to the power of 2 is going to be positive, so we have 3. X to the power of 3 divided by x to the power of 4. 1 times x cubed to the power of 0 is going to be 1. Negative 1 to the power of 3 is going to be negative 1 over x to the power of 6. So when you simplify it, is x to the power of 9 minus 3x to the power of 4 plus 3 over x minus 1 over x to the power of 6. So that's going to be the answer to this expansion question. Next example is expand x squared minus y squared to the power of 3. So we have x squared minus y squared to the power of 3. That's going to be 1 times x squared to the power of 3 y squared to the power of 0 minus 3 x squared to the power of 2 y squared to the power of 1 plus 3 x squared to the power of 1 y squared to the power of 2 plus 1, or actually it's going to be negative x squared to the power of 0 y squared to the power of 3. So when you simplify it, this one is 1, so x to the power of 6 minus 3y squared x to the power of 4 plus 3x squared y to the power of 4 minus y to the power of 6. That's the answer to this expansion. Next example is expand x cubed minus 1 to the power of 5. So the coefficient is supposed to be 1, 5, 10, 10, 5, 1. So x cubed minus 1 to the power of 5 is going to be 1 times x to the power of 3 to the power of 5 negative 1 to the power of 0 plus 5 x cubed to the power of 4 negative 1 to the power of 1 plus 10 x cubed to the power of 3 negative 1 to the power of 2. Again, when you add them, it's always equals to 1 and 5 plus 10 x cubed to the power of 2 negative 1 to the power of 3 plus 5 x cubed to the power of 1 negative 1 to the power of 4 plus 1 times x cubed to the power of 0 negative 1 to the power of 5. So when you simplify it, it's going to be x to the power of 15 minus 5x to the power of 12 plus 10x to the power of 9 minus 10x to the power of 6 plus 5x to the power of 3 minus 1. That's the final answer. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe to this channel. You can have access to many other videos regarding math, chemistry, and physics. Thank you for watching and have a great day.